Welcome everybody to this Quickstart tutorial on how to use Graphext to analyze and extract information really quickly and efficiently. For this tutorial, we're going to use the Titanic dataset, which holds all the passengers that were in the Titanic at the moment of the disaster. And we're going to try to predict, or at least figure out some patterns as to why people would survive or not, and see if there's anything hidden in the data. So let's just jump right in. We have here our new team. We can create a new project really quickly. We would usually just go to new data and upload something here, but for this example, we're gonna go into data examples, in which we have a myriad of examples to choose from. And in this case, we're gonna use the Titanic dataset. View project allows you to view a read-only project that the team made for us to check and to see what's actually available and possible to do the graphics, but it's read-only. For you to create a new project, you click in here to create project, and it will create a copy on your account that you can have full control over. So we can click in here and start working on it. So we have here all the data, which is 887 rows of all the passengers that were in the Titanic at the moment. And we have immediately a lot of information that it's very important, like the survived variable, which just tells us whether they survived or not. Their passenger class, which is their social class, like lower class, upper class, rich versus poor, their name itself, their gender, age. We have some family related data, which is how many siblings and spouses were aboard for each passenger, which is a weird aggregation. And then the fare, which is just how much the ticket costs. So let's take a quick moment to first prepare the data and make it a bit more readable and understandable for us particularly. I want to always have the survived column visible, so I will pin it to the left and it will always stay there no matter what. Next, I want to fix up the passenger class, which is a bit weird right now because for one, it's a number and it should be like a category of the three classes that they are considering in here. And we can, for example, rename it to have a bit of a classier name, if you will. And since now it's a number and this is not convenient because only three possible values, let's cast it as a category, which is just very quickly we can do it here. And this will now not represent numbers, but rather categories, the category number 3. But again, the category 3 does not tell us much. We would like to have like a lower class or upper class, right? So we can ask AI to do that for us. We can click in here in Graphext AI. It will pop up with this chatbot, and we can just ask it to transform the class column to have the value lower wherever there is a 3, middle wherever there is a 2, and upper wherever there is a 1. And we can just ask it that, and it will create a step in our recipe that it will in fact do that very quickly, as we can see here. So if we bring this to our first column, and then we could put this side by side and we can compare that lower is 3, upper is 1, and in fact middle is 2. So this is great. We already just did that. We can, for example, now name this as class, and why not just hide this for now? We don't need it. It's useful to have it there, but we don't need to see it right now. This is much more useful. In the same way, because we now can see it here and the actual column that we're going to use is here, we can go into the variable manager, which will actually manage all the variables we can see here. And we can, for example, hide the original one and bring the new one so we can have it always available here. We can click save, and this will now present this. And just as a last step to do with this variable, I want to make sure we can have an ordering to it, because lower is less than middle, which is less than upper. Right now, they're just 3 disjoint categories with no relationship to each other. So we could ask the AI to do that, but I want to take you through the recipe to see how it actually looks like to write one of these steps and how easy it actually is to write in this low-code environment. So we can click in the project steps or the recipe. We can have a quick overview. We see all the steps that we've made so far, which is casting the Pclass as a category or replacing the values, which actually was made by the AI. We can jump into the code and see that there are actually more steps. For example, this configure column visibility of survived as pinned, which is just what we did in the very beginning to pin it to the left. We can see here that replace values is affecting the Pclass column, just mapping the value 1 to upper, the 2 to middle, and the 3 to lower. That is all that the AI wrote for us. And because we want to order our categories, we can just write order, and we immediately get order categories in there as a first suggestion. We can enter. As we can see, it asks for the input column and the output column. The input column should be the output of the last step, which is replace values, which I want to take this column and basically order whatever came out of that. So I copy this and paste it in here in both. It will give me an error because the notation is not correct. Method order categories tries to overwrite the following columns. That is right. We are trying to convert the same column to a different type. But in order to do that, we must use the override operator, which looks like this. So we can just quickly say that this is just like this. We're now overwriting the column. But how do we tell it what categories do we need and what order are they presented in? For that, we can hover over here. We see the order categories in docs. There's a link. We can click and it will take us to the actual documentation. And we could read all this, but I would jump just into the example and see that it takes a column and then it gets an object like this with this curly brace notation. It expects a categories and then an array of categories. So we can very quickly just do that. For example, we get here, we say curly braces, categories, an array, and we say that upper is greater than middle, which is greater than lower. And this would effectively just order the categories themselves. We click here and we get out. We wait for it to finish. It's processing all the columns. And we would now have the same column, but now has this ordering implicit in it, which you can see that upper is above middle, which is above lower. Next up, I want to extract the title of the name, which is just Mr., Mrs., and so on. And we can actually ask the AI to do that for us again. We can create a new chat and say, extract the title from the name. See if it solves for us. And maybe sometimes it works, sometimes it does not. You have to be a bit more collaborative in case you don't get the expected results. In this case, it seems like it actually made a great job. And if we go here, this looks completely fine. So yeah, we have successfully created our new title. We now have a bit of a tidier data set. We can now start exploring a bit what's up in here, right? So we can, for example, just filter by gender, which looks very interesting, the age, or maybe the survived category. For example, we can see who survived. So we can see here that there's a bit of a overrepresentation of the upper class against the total percentage of people that were in the ship. That is, the gray areas that look like they are behind is the original representation. Like if we clear the filter, we see it's exactly that. So we go back. But the blue column now represents the percentage of out of the ones that we filtered. So particularly for the upper class, with respect to everything, they represented 24% of the whole ship. But out of those that survived, they represent 39%. So they clearly survived more than the other classes. Particularly, this is very clear in the lower class, which represents 54% of the whole ship, but only 34 out of those actually survived. So clearly they were prioritizing on the upper class rather than the lower class. We can see that is also very obvious in the gender. A lot more men died than women, because women represent 35% of the whole population, but almost 70% of all the women survived, which is not the case for men, which represented 70% of the whole population, but only 30% survived, which is very, very interesting. Clearly, we are prioritizing women, which is usually what you think about in situations of emergency, children and women first, which are the best candidates for keeping us alive here on Earth. We see the age distribution doesn't change much, although there's a bit of a spike here between the age of 0 to 5. Again, thinking about children, thinking about small children, which have a lot of future ahead. We can now, for example, get a bit more deep into the data with plot section. So let's try and plot, I don't know, for example, a survived class. the survived against the class, which gives us like a group, bar chart, or segmented, however you like it. And you can see here that it's very obvious what we were telling before. There's a lot more people that died that belong to the lower class than to the upper class. And there's a bit more people that survived from the upper class than from the lower class. And if we remembered, the upper class represented a lot less with respect to the whole population. So if this graph is very nice, we can actually customize it. For example, maybe, I don't know, change the theme. We can change, however, like the fonts, or maybe even just say here a number of people. So it's a bit clearer for outsiders when we are presenting this chart in any kind of project or tweet or something like that. We can extend this, we can extend this however we like. One of the things that I like to do is add titles. They are very, very important when you're presenting data. So this is distribution of class among survival. And maybe as a subtitle like how many people died or survived from each class. We can add some description here if you wanted. And in the footer, you would usually cite the source where the data is coming from, which is very, very important. In this case, this is a public data set in Kaggle, in the platform. So we can say data comes from kaggle.com. This is now presented as this. And we can, for example, export this chart as a PNG, as an SVG. We can even embed it in some web page or as a CSV, which is just creating this table as you can see here. I would love to download a PNG, and the name is also like the title itself, and we can just download our chart. And we can also save this as an insight if we thought this was very, very interesting, which is one of the things that I love most about this. We can save the insight. It gets the title that we put. We save the insight in here. And when we save it, we have this card in here. And the way this works is whenever you come to the project again, and this is just the clean project again, you come like tomorrow or whatever, you can go into the insights and just click here, explore insight, and it will restore the state of the application at that point. And even if you had some filters, like for example, only the females that are between this age bracket or something like that, it would reproduce all that, which is very nice. And just for fun, let's quickly jump into the correlation section, which is super interesting, which is hidden under here. And here we can basically search for any kind of correlation that we feel like it's going to make a difference or it's relevant to us. For example, we can click on the survived and see a quick overview of this variable against all the other variables. And this is sorted in descending order of mutual information, which is calculated as an index in the background. So we can see here that the gender is very, very important, and a lot of male died much more than women, and a lot of women survived much more than men did. And for example, the title, which encodes kind of the gender and age, also presents this as Mr's dying much more than Mrs. For example, the class also shows this very, very heavily, in which lower class didn't survive. So that's why this is so powerful here, whereas upper class actually survived a lot. We can have any other kind of distribution here. We could explore this in case we had a lot of columns to choose from. This is a very great way to just overview everything at a glance. So now let's quickly jump into how we can create a model. And to do that, it's super simple. We just jump into the wizard, and here we're presented with a lot of options to choose from. And we just go into the model section and train and predict. Here we're presented with the model composer, which just takes all the columns that we'd like to use to fit our model. And this is divided between the target, that is the column we want to figure out the value of, and all the factors that will take into account to figure out the target. So for example, we could drag and drop this in here and use the survived as a target variable, and then take the rest, put it here, but maybe don't use the name because that is not as important. We can review what are the rest of the variables because, for example, we don't need the old class, which is the one that holds the numbers. We can have the class that holds the actual values, and we can have the rest. Title is also good, although it's kind of similar to gender, but I think it holds a bit of age, so we can try and see how it works. Here, the model selection, we can see a cat boost classifier. We could either go with a logistic regression, though you don't need to adjust any of this, just continue. I would nevertheless like to cluster my data. And here we're going to choose UMAP, which is a very great model to cluster data. And everything you can leave as is, it doesn't really matter. This will create a predictive model with the cat boost regressor and the UMAP clustering model. It will create everything at once so we can have an overview of both the model and the cluster. We can click run, and this will take a couple of minutes. It depends on how much data points you have. It depends on a lot of factors, really, but it usually doesn't take much more than 5 minutes. So once it's finished, we can see here that a bunch of columns were created, like the target, prediction, probability, and error split, UMAP cluster, all this kind of stuff. Also, two new tabs appeared, models and graph. Let's start with models. This tab is presenting the results of our model and telling us how good it did based on some metrics that we're using. And the most important is the test and train accuracy. For the train accuracy was 94%, but for the test accuracy, which is most important, is 81%. And we can see here a quick little sum up of the model's performance per category, which is a confusion matrix, and tells you when the model did fail or not based on the categories. This means that when the actual value was false, the model predicted it correctly 52% of the time and incorrectly 8% of the time. We can toggle the totals, which are a bit more intuitive since this now actually adds up to 100%. But the recall is a more advanced calculation that takes into account the whole total of the data set. So this is now our model, and this would basically mean that whenever we had new passengers that we didn't consider before and we didn't know whether they survived or not, we could take a guess based on their information, and then it would output whether that person would have died or not. And I would love to jump into the graph view, which is very, very cool. And this is every single person on our data set, the 887, and they are basically clustered by their similarity. So basically, similar people are gathered around closely. This is very, very interesting when we, for example, allow me to move myself here in the right. And here we have the survived column that we pinned at the very beginning of our journey. And here we can color based on this. What this means is now every data point is colored based on whether it survived or not. To make this a bit more intuitive, let's actually edit this. Go here, false, let's quickly color it red. And for the true, let's color it green because it's good that they survived. We can save that. And we can see here that mostly all the people that survived are gathered around here, and the people that didn't survive are gathered around here. So this creates a very nice visual of what the distribution is of the people. For example, we can use the select tool and now select quickly this zone here, which mostly resembles cluster 5, right? And if we clear the filter and click on cluster 5, we can see that cluster 5 is full of people that mostly are female, mostly are upper class, and mostly have a title Miss, which is a bit of a younger version of a woman in this case. So this clearly adds up that younger women survived more than men. So this group is overly represented here. We can, for example, jump into other clusters, for example, this small one, and explore what this is all about. And here we can see that this is mainly male people of middle and lower class, which is very interesting to see, a kind of a exception to the rule. We can now change the color to the cluster, and maybe if we click here and add all the clusters that there are available, everything is colored up right now. One thing I like to do is maybe tweak the clustering coefficient to be a bit more tight. which means it joins more of the groups, so it doesn't really create a lot of unnecessarily small groups and gets a broader overview. We can save that, and we can have now less clusters, which is a bit noisy at times. So I hope you liked it. This is a very quick overview on how to analyze data with Graphext. For more, check out our YouTube channel, check out the links in the description, in which there's this project and there's a lot more resources to read and continue investigating upon. Happy analyzing. See ya.